this, what they're calling the difference quotient, is going to help us address a certain scenario in calculus. Okay, but right now we're working on the algebra that's going to be used at that point in calculus class. It deals with finding slopes and a thing that we call a derivative. But this will be a big component at some point in a calculus course. So it makes sense that we do kind of the legwork now with the algebra, so when we get there next year, the following year, it's pretty straightforward. Okay. They walk you through kind of the steps of this. Find f of a. So I'm going to take a and replace it for all my x values. Okay, so it becomes 3 minus 5a plus 4a squared, right? Okay. Then I find f of a plus h. Okay, so now x becomes a plus h. And I go through and I make that substitution. So it gives me 3 minus 5 a plus h plus 4 a plus h squared. Okay. The only thing here that you got to be cautious of is there's algebra to be done here. Okay. We need to, whenever we evaluate at an expression, okay, we make that substitution. If there's algebra left over that could be simplified, we have to do that. Okay. So we're going to go 3 minus 5a minus 5h, right? We've got to distribute the negative 5. All right, so this a plus h squared, that's a squared plus 2ah plus h squared, right? And then we'll run that 4 through there, using 4a squared plus 8ah plus 4h squared. Okay? The reason we do that algebra is because potentially there could be some hidden like terms that we can combine. Now here there are none, right? Okay. But again, there's going to be a benefit for having it in this format here in a moment as well. Okay. So now that we've got the components for what we call our difference quotient, we're now going to plug those things in. So the difference quotient says f of a plus h. So you take your 3 minus 5a minus 5h plus 4a squared plus 8ah plus 4h squared, and you subtract then f of a. Well, f of a is a quantity, so just be careful with this. I mean, especially when you get to calculus, you're going to want to be deliberate about this. You're not going to want to try to do things in your head. I think you're going to want to write it down first. So I'm going to subtract then that difference. And remember, this is all over h. Okay, because that's what the difference quotient structure is, right? Okay. Now, why did I put this in parentheses here? Because I'm subtracting a quantity, right? So I need to remove all of those things. If I don't do this, I will be only removing the 3 and adding in then these other values, which is problematic. Okay? But if I recognize that I'm distributing that negative, so it becomes what? Negative 3, a positive 5a, and a negative 4a squared, right? If we've done this correctly, okay, there should be cancellation occurring. Every single question we come across, there should be cancellation occurring in which the terms that you're left with all have an h in them. Okay, so the 3 doesn't have an h in it, right? So it should cancel. Does it? Yeah, that 3 right there cancels with that negative 3 right there. The negative 5a does not have an h in it. Does it cancel? Yeah, that negative 5a cancels the positive 5a. The 4h squared does not have an h in it. Does it cancel? Yep. 4h squared and negative 4h squared. Okay? That should happen every time in the difference quotient if we do it correctly. Okay? So what am I left with then? Kind of running out of room here, but I'm left with what? Negative 5h up top plus 8ah plus 4h squared, right? And it's all over h. What do they all have in common up top? They all have an h in them, right? Okay, so let's factor that h out. And then I have negative 5 plus 8a plus 4h, correct? The reason we would do that, we can recognize this h is a factor of what? It's a factor of 1, isn't it? H divided by h. So they cancel, and I'm left with my end result. That expression. Okay? And that's going to be key. It's going to be critical for us when we get to calculus, because something in calculus gets added here is that we talk about the limit as h approaches 0, meaning that what does that thing look like when h gets really, really, really close to 0? Well, when h is really, really, really close to 0, what's 4 times something really, 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 really close to 0? 0. So that 4h would disappear, and we'd be left with negative 5 plus 8a, and that becomes an equation to help us find slope of a curve at any point that we want to on the curve. That helps us find what we call a derivative. Okay. So that's going to be a process that we use many times in an upcoming class. Okay. But if you do the algebra, you can go through all that stuff. Then the calculus part's really easy. The calculus part is, okay, what happens when h becomes 0? And what we're left with. Okay. So the algebra is the hard part about a calculus class. Okay, so that's the hope in being able to address that one. Jamie.
Remember that one more problem? It's like 1 over the absolute value, so it's 2.5.
Yeah, can we wait till the end, because and maybe I have to hold you over in Wildcat time to do that one, but last class we kind of ran into some issues with time. But I can work with that with you individually if we need to. I want to do this one as well, because this one's a little bit different. There's some algebra that's involved here that we've got to remind ourselves of. Same principle, and it's actually a little bit easier in substituting here. If I go f of a, that's 3 over a plus 6, right? And if I do f of a plus h, okay, that's 3 over a plus h plus 6, correct? Okay. Now I plug into that formula. So we go 3 over a plus h plus 6 minus 3 over a plus 6. And that's all going to be over h. What do I need in order to, divide a fraction by a fraction? That top expression, a numerator, needs to be one concise fraction. Does that make sense to everybody? Okay. So, how do I make this thing a singular fraction? What do I need? Common denominator. Common denominator is going to be a plus h plus 6 times a plus 6, isn't it? Okay. So this is my common denominator for up top. What do I need to multiply this one by here? I need to multiply by a plus 6. So if I multiply the top by a plus 6, the bottom by a plus 6, it's going to be 3a plus 18 up top, correct? Is that okay with everybody? What do I need to multiply this fraction by to get that common denominator? Okay. So now it's negative 3 times a. It's negative 3 times h. And it's negative 3 times 6. Is that all right, everybody? And that's all over h. Take that and come down here. Actually, let's just... What happens before I take it down here? What's going to happen with my 3a? That cancels out with the negative 3a. So that goes away. That goes away. What's going to happen with the 18? Cancels out. What am I left with? Negative 3h up top. On the bottom of that first fraction, I get a plus h plus 6. A plus 6. And on the bottom down here, I'm left with h, right? Okay. Now, whenever you're doing this, do not multiply the a plus h plus 6 and the a plus 6 out. Whenever you have a denominator that has the potential to FOIL it, do not do it, okay? And if you have a denominator that looks like it could be factored, factor it, okay? We want it looking like we have that denominator and numerator right now. The a plus h plus 6 times a plus 6. Because the potential is down the road with other algebra, there might be an a plus 6 show up in a numerator that cancels the a plus 6 that's in the denominator, right? But if it was FOILed out, you would not be able to see that. It'd be disguised as a prime sum of something else. Does that make sense? So, do not multiply that out. But when I have a fraction up top and a fraction on the bottom, okay, what do we do to do this overall division here? Multiply by the reciprocal, okay, of the denominator, right? So we take 1 over h, okay? The idea of that, guys, is if I take 2, I should take 2 divided by 3. Is that equivalent to taking 2 times the reciprocal of 3? Absolutely, right? Okay, so division is the same as multiplying by a reciprocal, okay? So that's how we're going to address division of fraction. What happens with this h here in the bottom and this h in the top? They're going to cancel. And now I'm left with -3 times 1 up top, so you get -3. And on the bottom, I'm left with a plus h plus 6, and a plus 6. And that would be my end result for that difference function. Okay? So those two examples hopefully will help you work through. I think the last 4 questions maybe are targeted in that. Okay, and that's one of the biggest uses right now for evaluating and substituting into functions these expressions like a and a plus h. A lot of times in calculus you use x and x plus h, but it doesn't matter what the variable is. Okay. All right, so let me